Okay, so what we're going to do now is we're just going to talk, this video is going to quickly talk about the problem solving strategy that I use, which a lot of uses for solving these problems. And then the next couple videos will be just some examples using that strategy. And then we'll focus on specific types of forces that you could run into when doing these problems, okay? So the first thing is what is the strategy? And I like to just kind of make it simple. Right, and so the way I think about Newton's laws is that it can be broken down to just three simple words: draw, sum, solve. Okay, that's it, right? There's three simple words, three steps in doing Newton's law problems. The first step is draw. Okay, what this means is that you're going to draw the free body diagram. Okay. Now, most of you guys probably have taken AP Physics or a physics class where you know what a free body diagram is. All it does is just simply identifies all the forces that are acting on the object for all objects involved. Now, what that last statement kind of means is that you may run into connected objects problems. Okay. You may run into objects that are touching each other. Okay. You may run into two ropes that are undergoing a tension. Okay. But you have to have as many free body diagrams probably as you have objects that or potential systems that you can use. Okay, and basically free body diagram, we're going to draw a box or a dot, and then we're going to draw forces off of that. Okay, you can draw them relative in size if you want, and sometimes on the AP test, if it gives you kind of like a grid, then they want the relative size. If it just says, hey, on this dot, draw the free body diagram, then you can just put, they may or may not take off for that, hey, this should be smaller than the other one, okay? So you can either do a box or a dot. It doesn't have to be intricate, right? So if it says draw a free body diagram of a car, a box suffices for that car. You don't have to draw the physical picture, okay? So this box is representative of, a car, a crate sitting on a floor, an elephant, okay? Now, the second step is to sum. So during this step, you're going to find an equation that represents the net force. Sorry, that T looks like an F. Okay, so we're going to write an equation. Okay, and generally it'll look like, Fn minus Fg equals 0. Okay. Now, because this would be something in the horizontal direction, all right? If it's an object on a table, it's not being accelerated. But this 0 is representative of m times a. Because remember, that is what the sum of the forces equals. So this is just simply the sum of the forces, all right? And this would be in the vertical direction or in the y direction. Okay. And then that 0 again. You're it's either going to be set equal to 0, right, or m times a, based on what's happening. If you're looking for an acceleration, you're going to set it equal to m times a, okay? If the forces are balanced, you're going to set it equal to 0. And then the last step here is simply solve, okay? So what do? Now we're just going to simply solve what we're looking for, okay? So what happens is sometimes you'll need the vertical side to plug it into the horizontal side. That's very common when you have friction problems, because you need the normal force on the vertical side to do anything with the friction on the horizontal side, or vice versa, just depending on what the situation is. And also understanding that if this is a dynamics problem, right? So dynamics, if I can spell this, okay? You need the acceleration from either motion, right, or force, and then you're going to plug it into the opposite. So once I have that acceleration, okay, then I would just plug in, right, if I have to find acceleration from force, I plug it into motion. If I have to find the acceleration from motion, I plug it into force. Where does that really apply? When we do problems involving friction, because a lot of times you'll have to find the acceleration based on the friction, And then the question is going to ask you something along the lines of how far did it travel, how long did it take to come to stop, but you need the acceleration from the force side to plug into the motion side. Okay, or it could be vice versa. You can find the acceleration based on the motion question and determine the coefficient of friction between, let's say, tires in the road. Okay, all right, so that's just the basic strategy of draw, sum, solve, and then we're gonna talk about some example problems in the next bunch of videos.